we are going to look at writing the equation of a transformed graph. So if we look at this graph, we can see that it is an exponential function. And the way I know that is because if I look, I can say, okay, it has a horizontal asymptote at y equals -4. So the horizontal asymptote at y equals -4. Just compare the two sides. So this one clearly leveled out while this one is still increasing. Can you notice it crosses over? So while I guess it's a very, very slow change in the x, it is still changing the x, and it's not limited in the same way that the y values are limited at -4. In terms of transformation letters, right, we have A, which is a vertical dilation, H, which is a horizontal translation, and then K is our vertical translation. So that would be this movement right here of what was y equals 0 is now y equals -4. Exponential functions, right, the parent functions of exponentials, notice all have the asymptote of y equals 0. So if you want to think of it, y equals 0 is where it starts, but now it's been shifted down 4. In terms of finding the base of the exponential, we'll get to that at the end. So as I was showing, all parent functions also have a point at 1, 0, this y-intercept. Notice how as I change what type of exponential function, while the graph is changing, that point of 0, 1 stays the same. So the way we're going to use that point of 0, 1 is we're going to say, okay, if this is always on an exponential function no matter what, then in order to know how it moved, I need to see where this point of 0, 1 went to. And to do that, I need to understand the left movement, right movement, down movement, up movement. I already know the down movement. We already said that K, which is up and down, is -4. So I know that this point right here of 0, 1 is going to move down 4, meaning the y value is going to change and go down 4. So now I'm right there. So now all I have to do is need to find, okay, well, how do I need to move so that it now matches my graph? Well, I need to move it 2 to the left, -2, and then I will see that it's now on my graph. So that point that's 0, 1 gets transformed down 4, left 2, and that's going to be our H value. The next thing is finding the A value. And for ease, we will assume that there is no vertical dilation. We're only going to be writing the equations of graphs that do not have vertical dilations. That leaves us between the two values of 1 and -1. Well, the difference between 1 and -1 is if it's a -1, that means it's been reflected across the x-axis, which means it's going to turn my graph into a decreasing function. Okay, I'm looking at exponential growth, so reflecting is going to turn it into a decreasing function. Well, if I look, this is an increasing function. It's above my asymptote, so that's going to tell me that A is positive. It's a +1 since there is no vertical dilation. And then the last thing I need to do to write my function is I need to know the base of my exponential. As I showed you earlier, I went through a bunch of different possible bases. We just need to determine which one is it. So let's go ahead and write what we know. So we know that it's going to be y equals A times B dx. Well, we know A is 1, so we can just go ahead and get rid of that because 1 times anything is itself, so we don't need to write it. So now we have x minus h. Well, we know h is -2. So x minus a -2. We don't write it like -2. We write it as +2. K is -4. -4. Okay, so we now have every single piece except for whatever this base is. So the only thing we don't have now is the base. Another important point on the parent function would be the point 1b. Which point on the graph appears to be the transformed point from 1b? So again, just to kind of emphasize what we're talking about this point 1b, is notice on 2 to the x, right, we always have that y-intercept, and then the point just to the right, where x is 1, is always going to be whatever the base is. So 2 to the x gives me the point 1, 2. 3 to the x gives me the point 1, 3. 4 to the x gives me the point 1, 4. And it's always going to be that point to the right of the y-intercept, or in this case, the point that was transformed from the y-intercept. So if we look at the point to the right, we will see that it's at -1, -1. Well, the trick then from here to determine the base is we just need to see how far away it is from the asymptote. Because in the same way, right, when I have 2 to the x, well, 1, 2 is 2 places away from the asymptote. 1, 3 is 3 places away. So however many places away from the asymptote is going to tell me my base. So when I'm 3 places away, my base is going to be 3. Let's take a look at another one. Go ahead and pause the video and try this on your own if you want, and then check back and then see how you did. So we no longer have those training wheels that we did in the first one. A little trick to help you with Desmos is if you want to make a note without making things or like equations that are going to go on the graph, if you hit this plus sign and go to note, that's going to give you the ability to type things in, again, without making them appear on the graph or making them look like equations. So we need to find A, H, K, and B every time we do these, right? That's what we're filling in when we're writing our equation. Y equals A times B, dx minus H plus K. So these are all the variables we need to define. Well, let's just make some general observations without really going too in depth. So the first one is if we just look at A, remember A has 2 options, 1 or -1. And the difference being 1 meaning it's increasing, -1 meaning it's been reflected and it's a decreasing function. Well, we can see that it's increasing, so it needs to be 1. Okay, the next easiest one to determine from an exponential is the k value. How do I do that? Well, let's define what the asymptote is. Well, it's going to be y equals 2, because again, my values are approaching 2 while my y values are going up as x is going up. So there is no vertical asymptote, it's a horizontal asymptote again. And y equals 2 tells me that k is 2. So I'm halfway there. The next thing I'm going to find is I'm going to find my h value. So we're always going to start with the point 0, 1 and find the new point on the graph. So 0, 1, we're going to change the y value. We said that k is 2, so we're going to say OK plus 2. So it's moved up 2. My y, this point right here, 0, 1, is going to move the same way up and down as the asymptote did. So before we moved it down 4. Now we're going to move it up 2 just like the asymptote. And now we just need to slide it till it falls on my graph. And I'm going to slide it 1, 2, 3, 4, 5 places to the right. So remember, when I do that, it's going to be 0 plus h, 0 plus k. So h is 5. So now I have those 3 down. I just need to find the base. And again, to find the base, I'm looking for the point that is 1 to the right. So if my point here is 5, 3, I'm looking for 6 And the y value where x is 6 is going to be 6 comma 4. Count to the asymptote 1, 2. My base is 2. So now it's just a matter of filling the cell in. Well, A is 1, so we can get rid of that. B is 2. H is 5. K is, oh, not 3, sorry, 2. And there we go, it falls on our graph. All right, go ahead and pause the video and try this one. So we need to define the variables A, H, K, and B. But just like before, we're going to make the observations before we get too specific. So let's start with A. Is this an increasing function or is it decreasing because it's been reflected? Well, we should see that it is a decreasing function. So A is going to be -1 this time. Now let's focus on my asymptote. Well, this is going to be a horizontal asymptote, so it's going to be an exponential function. But the horizontal asymptote is located at y equals 6. So my asymptote that was y equals 0 moves up 1, 2, 3, 4, 5, 6 places. So K is 6. From here, I need to now look at the ordered pair 0, -1. The reason we're looking at 0 and -1 is because my graph has been reflected over the x-axis by the fact that it's a -1. So it's 0, -1. If you're having a hard time thinking about that, just remember whatever point is always going to be 0, A. So it's either going to be 0, 1, or in this case, 0, -1. And we know that it's been moved up 6. And then to make it follow my graph, I need to move it 1 to the right. So H is 1. Then the last thing is find the point that's to the right. So 2, -4. Oh, forgot my comma. And count up to the asymptote. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my base then is going to be 10. So we put it all together. Y equals, okay, -1. We don't need to include the 1 because we just don't need it because 1 times anything is itself. So -10 to the x -1 plus 6. And we will see that it falls right on the graph.